Here we are looking at example 2a from our 4.3, 4.4 notes. We're asked to factor the following, and in just looking at this, we do notice that we have x squared plus 6x plus 9. There's no greatest common factor that we need to go ahead and pull out, so step one's kind of skipped in this case. So we're just going to go ahead and jump then to step 2, which is pretty much breaking this down into a pair of binomials and just kind of seeing what goes inside. Now, in order to get this x squared right here, we know that we have to have x times x, because that is what will give us this x squared right here. Now, in looking at this last number 9 and creating that list, we have 1 and 9. 1 times 9 gives us the 9. We also have 3 times 3, which also gives us 9. Okay, and now when we look at our two numbers, we notice that 1 and 9 is not going to in any way combine to give us 6x that we're hoping for. However, 3 and 3 will. So we kind of narrowed it down that our numbers are and have to be 3 and 3. Now, because everything is positive, we have no choice in this matter that the binomials now are also going to be all positive. And just to kind of help illustrate what's happening here is we have our x squared, just to kind of do like the whole check thing. We have x squared, and then we have x times 3. Well, that does give us 3x, and then we also have another 3x. And then, lastly, the plus 9 at the end. Now, one could argue that we have this x squared, and this does in fact combine to give us 6x. One could argue, though, that instead of combining to get to give us this 6x that we're hoping for, you could say 2 times the 3x's, because there really are 2 times this number and this number. Because again, that's what we have right here. We have those two numbers being multiplied together. We have 2 of those 3x's that are being multiplied together. And then lastly, plus the 9, or instead of rewriting 9, we could just say 3 squared. Now, the reason why I really want to illustrate this is because I think it's going to help us out with the definition, because the definition is a little bit weird at first. And when we just look at it, that's why I kind of wanted to jump to the example first, kind of see it with some numbers. We have this a squared. What that really was kind of like the x being squared. And this plus 2, and that was really coming from how we had 2 3x's, because again, we had 2 of them right here. And then the a and the b that it says in the definition, right here, we have the a and the b. That's really the product of this x and the 3, and the x and the 3 right here. So that's pretty much what our a and the b were. When we saw it below, we kind of had this 3 representing the a. It doesn't really matter if it's the 3 or the x, but imagine these for a moment kind of flip-flop just to match the definition. But you still end up with the same exact thing that we were talking about below. Okay. And then lastly, plus our b that's being squared. Well, that's kind of like our 3 times our 3, the last 2 things being multiplied together, giving us then the 9 that we, ended up with. So the definition looks a little bit weird. It does fit. I don't normally like to teach this approach, but what I do like to illustrate, especially, is noticing right here how when we factored it down, we ended up with x plus 3 times x plus 3. Okay, x plus 3 times x plus 3 is the exact same thing as saying something, this x plus 3, times itself, or x plus 3 quantity squared. All right, we're pretty much taking something and multiplying it by itself, or essentially squaring it. That's the exact same thing. And as a result, anytime you kind of see this pattern of a squared plus the product of these 2 things being multiplied together times 2 plus the b squared, then that's really the same thing as saying that same binomial being squared, x plus, well, in this case, not x plus 3, but a plus b being squared. All right. And I know it's really kind of maybe a little bit trippy with the definition here because of all the a's and the b's, but I do guarantee you that as you start to see a lot more examples like these, you're going to kind of start to be more familiar with this guy right here. And that's a good thing because you can actually solve some things pretty quickly using that method. All right. Now, just looking at the second one, the only real difference here is that we have this negative here. So just imagine that if this instead of a positive was a negative, and this guy was a negative, well then we would end up with negative 3x and negative 3x to give us negative 6x, which is pretty much just the opposite of what we were doing before. And then lastly, when you multiply the two last numbers together, negative 3 times negative 3, you still get that positive that you're kind of seeing here from the definition. So the only difference between this one and the one on the left was the sign inside that parenthesis being negative. But it's still now a minus b quantity squared. Okay. Now looking at the definition for the a squared plus, and that is example 2a from our 4.3, 4.4 set of notes.